If I want to become an elite video game player, an elite athlete, an elite programmer, I need both of these. You learn this stuff better from playing sports or video games than you do from school. Well, I didn't understand all that code I wrote up until this point, and now that resource isn't working for me anymore. I have a question that Stack Overflow can't answer. Intelligence is not one-dimensional. By virtue of being good at one thing, you can be bad at another. And by being bad at one thing, you can be good at another. Now, I intentionally worded this as sort of a strange philosophical statement. I honestly believe that most of you guys watching already agree with this statement, even if you don't already know it yet. I think humans intuitively already understand this, either through experience or maybe they're just born with it. I don't know. And if that's really the case, why should you even listen to what I have to say? Well, I think by being aware of how your brain works and how the world works and how things work, it gives you really an incredible amount of power. Instead of fighting against nature, you can actually learn how to control it. Instead of this, I could have used some platitude like diversity is our strength, or if you judge a fish by its ability to climb a tree, it'll live its whole life believing that it's stupid. But if I did that, I think my message in this video would be ignored. People already have certain feelings about those kinds of platitudes, even if those are not so different from what I'm trying to say. At least in some ways they have overlap. And I want to start with a clean slate so that I can convince you why my message is important and why it's helped me so much in my own life, and hopefully it can make a difference in yours as well, even if only a little bit. The message I'm trying to make, whether you agree with it or not, is about a way of thinking. It's something that I believe can be universally applied. So please don't take this to mean like it's related to leak code or something. In the sea of all my leak code videos, I made a video the other week, this one. And if you go to the comments of this one, in the video I talked about like a leak code problem. And even though I mentioned my point wasn't about like this leak code example or this comment, unfortunately, I feel like most of the comments really made it about that specific example. Maybe it was an interesting example to discuss. I was talking about learning different programming languages, and I'm not like mad or upset about that. It just is kind of disappointing because I want to have like a broader discussion. But in that video, I did see something interesting to me as well. In that video, I talked about learning, and I mentioned I would talk about it more in a follow-up video. This is that follow-up video. I talked about how if you have a kid and you buy them a new video game, and one of the kids, instead of playing the game, they start reading the manual, and they want to understand every little thing. I mean, before they even pick up the controller and learn how to use the controller, they're figuring out, okay, which button does what. And then on the other side, you have a kid who is doing the opposite. They just start mashing buttons right away. And I said that, well, the kid who has bias for action, the kid who's just going to start doing stuff and then using those kinds of data points to learn, rather than reading the manual, which is, really not something brains and humans are wired to do. That's not how you're supposed to learn. You learn by doing. And I said, well, the kid that plays is going to learn much more quickly. I would bet everything on it. Now, that was somewhat of an oversimplification, and I got a very interesting comment in response to that. Well, I got two comments that I wanted to point out. This one, where he says, very bad take. As a Master League StarCraft 2 player, I figured out the first thing you learn about when doing anything hard is to get the books, the advice of the pros. Then you can start to train when you actually know what you are training for. And I'm not actually mad at this person's comment. I'm glad that they commented this because that was one of the things that I wanted to expand upon. And it makes me glad that there are people like this that are actually watching the video, because that means people are actually paying attention. That means you guys are actually smart, because this person in some ways is exactly right. Now, another person commented something in a slightly nicer way. They said, an important thing to consider here is that the best answer to any real world situation is it depends, because almost every time you have to weigh the pros and cons and have to come up with a solution that is the culmination of trade-offs and decisions you made to come up with that solution. And I think this one, well, probably the reason why it got more upvotes is because it's exactly correct, more so correct than the previous comment. Now, let me try to tell you a little bit of what I mean and try to outline the rest of this video. I'm going to talk a little bit about some like personal anecdotes and a few of my life experiences. You guys know I don't really like to get too much into my life. I don't think I really need to make the point that I'm trying to make, but I think in this case, it's pretty relevant. I'll do a bit of that. I'll talk a little bit about the book, Thinking Fast and Slow. This is a book that was written in 2011, and I actually have not read that book. I have like done a little bit of research on it, and I think in many ways that book actually supports some of the points that I'm trying to make. But also keep in mind that that book, a lot of the sources that it has used have not really been verified or repeated. Then I'm going to get into kind of some visual ways of thinking about this stuff. When I say intelligence isn't one-dimensional, in some ways you can take that to be like a radar chart or whatever it's called. Sort of like a video game like skill tree where you have different skills, but you can't have all of the skills. You have a limited amount that you can put into it. And probably most importantly, I'm going to talk about how these things and understanding like these things can help you in, most importantly, like your job and your profession. I think most of you guys are students or work in tech. And I think these things are applicable to that, but also applicable to even more things, quite frankly. I'm just not the type of person that gives concrete, like 1, 2, 3 steps, like just follow these exact steps and everything in your life will be okay. And the reason I don't do that is because that never works. It just never works in life. People think it works. That's what people want. Hey, just give me 1, 2, 3 steps and then just give me those instructions and tell me what I have to do and then tell me how my life is going to end up perfectly. And, that's how you kind of become a salesman. It's very easy to sell to those people because they're looking to get something, but I don't like to do that because it doesn't work. I think you have to interpret what I'm trying to say and try to apply it to your own life. I can't tell you exactly how to do that. Once again, let me go to a comment that I got. These mistakes, he's quoting me in that video, these mistakes held me back for so long. And then he says, proceeds to get 6-figure job at Google and Amazon, becomes famous among devs everywhere due to how good he is at explaining DSA problems all by age 23. Okay. Again, I'm not mad. I'm not anything. Maybe I'm a little bit flattered that people think so highly of me. And if I'm being honest, in some respects, it's true. I mean, a lot of that, I guess, in some ways was due to luck, but I was very, very good as a student pretty much my whole life. Whenever I wanted to apply myself, I was pretty good. There were some periods where I did very, very poorly in school, like in high school for like a 2-year period, mostly due to like personal reasons. But for the most part, I took a lot of advanced math classes, advanced physics classes in high school, and I did exceptionally well. I was typically the top of my class, and this was like, a class like taking AP Physics, where you're doing like college level physics, things that quite frankly, a lot of computer science people hate. People hate that stuff. People hate calculus. I was exceptionally good at it. And I thought my whole life, well, why is that? People like to have an explanation of why. And the simple answer is I'm just smarter than everybody, right? And I believed that. I honestly believed that most of my life. But the problem with an explanation like that is then when there were parts, whether it was like in school or in internships or jobs, when I wasn't doing so well, what I thought to myself? Well, the explanation must be I'm stupid, right? And even at the time, logically, I knew that that wasn't quite true. Even in high school, when I thought to myself, why am I doing better than everyone? The easy answer was I'm smarter, but the real answer, which I kind of knew, but I didn't fully grasp it, was I just enjoy this stuff more than anybody else. I saw my peers. They were studying more than me for the same exam, and they would get a far lower grade than me. It's easy to assume I was just smarter than them, but the one thing that most people don't consider is I enjoyed it so much more. I really can't tell you how much I loved math and physics. I loved it so much that throughout the rest of my other classes, I would be thinking about different kinds of physics scenarios, different kinds of equations. I would be given some equation one day in my calculus class, and then I'd be thinking the rest of the day, well, why does that equation work like that? I would go home, take a shower, and I'd just be thinking about math equations. That sort of repetition made it so I didn't really have to study. When you're genuinely curious and enjoy something, it becomes pretty easy. Frankly, many of the students in those classes were probably innately smarter than I was. But ultimately, what I'm saying is, it was not a one-dimensional answer of why things worked out the way that they did. And the unfortunate thing is that what made me so good at math and physics and really understanding really deep, subtle concepts, even when it came to programming, functional programming with ML in college, I got straight A's in everything I did, and it felt easy. I really didn't have to do much. I just kind of cruised through college thinking I'm just a little bit smarter than everyone else. And when I got my first internship at a bank, Capital One, it's easy for people to look at it and say, well, he did pretty well. He got that internship. And then after that, yes, it's true. I got a couple jobs. But let me tell you something about what happened at that internship. One of the first things I had to do at that internship was learn about Docker. That's what they told me. So go through some of the documentation, do some of this stuff, learn about Docker so that you can use it in your project. This was like 2019, by the way. And so I approached it the same way I had approached every other type of learning that I was doing at that point, and it turned out to be completely wrong. I went through so much documentation. First of all, the steps that they told me to do was just kind of like go through like the quick start, just, create an image or create the Docker file, create an image, run the container, do like kind of like a hello world type project, and then connect a few containers together, Docker Swarm, like a few pretty basic things. I mean, you could do this stuff relatively easy just by copy and pasting commands without really understanding what you're doing. And that's what I was trying to avoid. I was like, okay, if I'm going to be doing anything, I'm going to understand everything I'm doing, because that works in math. If you understand exactly why an equation works, man, you can just like solve so many problems with that. If you deeply understand algebra, calculus is going to be a breeze. So I thought, if I deeply understand Docker, everything else is going to be fine. And maybe to some extent that's true, but things of this nature with high amounts of abstraction are not the type of things that you should be deeply understanding. That's kind of the point. And so when I went through the documentation, I saw these big keywords, hypervisor, all this like random things that I didn't really know. And I thought, okay, I'm going through this, but let me stop before I actually go through this. And I learned exactly what a Docker file is, what an image is, and a container, and how like the things work in that like process. Let me deeply understand hypervisors. I went down a bunch of rabbit holes, spent days reading documentation, doing those things, and frankly, wasting a lot of time, because even after all of that, I really didn't understand a lot of that stuff. And even if I did, I was never going to use those concepts for the next several years. I was never going to need them. So I kind of just forgot all of that stuff anyway. And the worst part is, I didn't really have that great of an understanding of Docker images and containers and stuff like that. What had worked for me in the past was not really working so well right now. And I recognized that. After like a week, I was like, okay, so this is not the correct way to go about it. And so I'm just going to kind of do the bare minimum of what I need to know and learn things as I need them. And I'm just going to focus on Docker right now. And I wish I could tell you that after this, everything was just smooth sailing from there. I had learned my lesson. Now, anytime I needed to do things on the job, I approached them in the correct way. I wish I could tell you that, but that's not how things work. When you've been doing something a certain way for so long, it becomes so ingrained. Changing is hard. And not only that, I literally forgot this. Every time I had struggled with other things going forward, I just kind of forgot this lesson. And so that's part of the reason I'm trying to like put it together in a way that's like presentable and understandable, because once I did that for myself and I really reminded myself of these things, that okay, when you're in certain situations, you want to approach things differently. Things have gotten so much easier. So briefly, let me go back to the video game example for just a second. The reason I kind of oversimplified that example where one person is reading the manual, RTM, read the manual, and maybe the other kid is mashing buttons, because they're both correct. That's the hard thing. Two different things can be true. Both things can be true, and it's our job as humans to figure out which one to do at a certain time, and then to train ourselves to do that. The reason I said that this approach was preferable is because I was talking about little kids. Little kids aren't so good at reading manuals, even if they understand the English. But little kids have neuroplasticity. That's like the scientific term. But what that just means is, god damn, their brain will take data points in and do literal magic with them. You teach a little kid chess. You don't give them a textbook if they're 5 years old, because I'll tell you, they'll take those data points as they're playing chess hours and hours a day, and they'll figure out those patterns themselves in a way that's more understandable and more quickly than they could reading a book. When you're teaching a baby a human language, English, Spanish, Hindi, whatever, you don't give them a book. You just start talking to them. Those data points going in their brain do literal magic. That's why I said this was preferable. But it's exactly true. You need both. There comes a time where you rely on instincts or the fast part of your brain. And there are other times where you slow down. You rely on deliberate things. You calculate things. You re-examine the way you're approaching something, and you think, okay, is this the correct way? Is this the correct strategy? If I want to become an elite video game player, an elite athlete, an elite programmer, I need both of these. And that's one of the things that school does not teach you. You learn this stuff better from playing sports or video games than you do from school. School, in some respects, is an abject failure. So whether you were like me and you were like an insanely good student, or you were a very poor student, that's only one like data point. I didn't really believe it as a kid. I thought like the people that are saying, hey, school isn't everything, I thought those were just the stupid kids making excuses. And maybe some of them were, but there's a lot of truth to it. And so I'm not kind of done like with this thing yet. This is like the spectrum I'm going to talk about. Well, one of the spectrums, but let me just kind of finish up the personal anecdotes and kind of wrap up a little bit of my story. By the way, I did get a return offer at Capital One. I didn't accept it because in 2020, I started working at Big Bad Amazon. And I made a video about this. I won't go super in depth. Kind of had a breakdown. There's a lot of reasons into it that I didn't talk about. I probably won't talk about unless somebody really, really wants to know. But like I said, there's a lot of things that went into it. It was not a one-dimensional thing. I wasn't doing well at Amazon by my own admission. And so I actually left 2 months after Amazon. I guess one way you could think about it is I was smart enough to promote myself to customer. But I mean, I considered it an abject failure. But I did take that opportunity to learn a lot of things. I mean, if you think I stayed down from that, you're wrong. But, and then, between, I think it was about a year and a half gap between that. And that entire time, believe it or not, I did leak code problems. I did this YouTube channel, or the other YouTube channel I started, just did a lot of leak code, explained leak code. I was pretty damn ready for any interview I was going to see. That was my strength. Like I said, I went into my comfort zone. That was my comfort zone, just doing deep things. How many personal projects do you think I did during that time? How many programming languages do you think I did during that time? I didn't do nothing, zero. You might not believe it, and you might not believe the next thing I'm about to tell you. Okay, in 2021 then, I got a job at Google. And I'm not kidding when I say 1 year into that job, I did get a promotion. And so once again, you could take that to mean I'm just a genius. And it was just a junior position. Let's be honest. It's not too hard to get promoted from junior to like mid-level. There was some luck that went into that. I could tell you I'm just smart. I could try to sell you a bunch of things, say, hey, buy from me. Look how smart I am. But if I were to tell you why I was successful in that respect, I have 2 reasons. I did have good programming fundamentals. I knew how to use like the command line. I knew a few programming languages pretty deeply. I knew front end, back end, HTTP. I knew the basics pretty decently well. But more importantly, or maybe equally as important, I knew how to learn. Not just how to learn in school. I mean, that part of my brain was built up pretty strongly. I knew how to learn, but I knew the other things as well. I knew the spectrum. I knew how to switch into 2 different modes at will. I could do that. I had not just learned it in like the snap of a finger. I had built up that other part of my brain that I had identified was lacking. And so with this, I was able to do exceptionally well at Google. And so now, enough about me. Let's talk about you, and let's talk about other people and how I can, in some ways, offer you advice. Now, I want to briefly mention this book now, Thinking Fast and Slow. The main thesis of this book is that there's two parts of the brain, one part that goes slow and one part that goes fast, or rather that's like the modes of thinking that people have. So for example, like you're doing a math problem, or you're making a decision, or you're being like data driven or something like that, you could say that's slow. I would add a bunch more to that. I would even extrapolate this to how companies work. You got the companies that have a lot of bureaucracy and they move very slow, and then you got the move fast, break things company. And you might say, well, which one's correct? Well, they're both correct. Even within that company itself, like on the macro level, you could look at it like this. You got big things and you got small things, you got fast things, and you got slow things. Governments go slow, some companies go slow, some things go fast. On the micro level, though, you'll find even within a company, there are parts of it that have to be very careful, that have to go slow, the legal parts. And when you don't have that, like you get a Facebook and they leak a lot of data and things like that. And then people say, well, look at Google. Google is so stupid. But hey, Google hasn't really had as much data leaks and things like that as Meta. So you can see why they have a different strategy than other companies. They don't really need to do much because they're a monopoly. Again, I'm getting kind of off topic, but I'm saying that even what I'm saying, even the things that I'm saying are not quite one-dimensional, even though I literally drew it as a spectrum, which is one-dimensional. So I just want you to know that that's not lost on me. I'm recognizing that. Now let's talk about programming. Let's talk about how sometimes you can overthink the hell out of things when you're programming, and sometimes you can tend to underthink. And sometimes you need to do both. And sometimes you need to be somewhere in the middle. And sometimes, like on the micro level, you need to switch from one to the other, and you need to be able to recognize when to do that on the fly. For example, if I'm programming something and I don't know what to do, I'm stuck, I need to figure something out, some people's first response is to go to the documentation. The documentation sometimes is pretty dang verbose. You got to search through that. I know nowadays nobody reads the docs, but back in the day, you go through the documentation, right? You're going kind of slow. Read the docs, read the manual. The other thing was, well, depending on what the issue is, maybe somebody has seen it before. Maybe let me ask my coworker, or maybe let me go on Stack Overflow, and probably I'm not going to ask a question because I don't want somebody to, get mad at me for no reason or mark my question as a duplicate, but maybe the same question's been answered on Stack Overflow, and maybe I see the solution and maybe I understand what it is and then I implement it into my code. Or maybe I don't quite understand what it is. I take that chunk of code, I copy paste it, I see if it works or not, and it does. And then it worked. I mean, that was the correct solution, right? I just saved myself time. And, sometimes as software engineers, you gotta do that. You can't understand everything. When I first started working at Google, that was one of the things I think somebody mentioned to me. It's like you're reading some docs, it has 5 different links to other documentation, which are like prerequisites of the documentation you're trying to read. Each of those 5 docs have more docs linked. And if you're just trying to completely understand something, you're going to be doing it forever. I mean, you could think of that process of like one piece of documentation linking to others, and then those docs linking to other docs. And then you could think about it, well, do I want to run a DFS on this documentation or a BFS? Well, the answer is sometimes none. Sometimes you want to underthink. You don't need to quite understand every little thing that's going on, but if you do that too much, if you copy and paste too much, nowadays, if you chat GPT too much, you get to a point, well, I didn't understand all that code I wrote up until this point, and now that resource isn't working for me anymore. I have a question that Stack Overflow can't answer. That was like the problem back in the day. Nowadays, the problem is I have a question that ChatGPT can't answer. Claude can't fix my code. Cursor has written so much code, now it doesn't know what to do with it. Now what do? Now you're at the point where you're pretty damn stuck. You're going to have to move pretty slow. And maybe, I mean, maybe that was the best thing that you could have done. Or maybe if you had been somewhere in the middle, you understood at least a little bit of your code and you relied on AI a little bit less, you would have been far better off. I think most of the time, the answer is somewhere in the middle. You got a lot of people nowadays, the AI people. AI is going to cure cancer and do every single thing, but it gets stuck on some very trivial issues nowadays. I mean, maybe it'll be better 10 years from now. I can't say. You got the other people saying, I don't use AI for anything, which I don't know why you'd be doing that. Even over 2 years ago when I left Google, they had already started implementing some AI things that, quite frankly, the work that I was doing before we had like GPT and like these AI assistants, a lot of the bugs that I ran into would have been easy to fix with AI. So I really don't believe that you should never be using AI either. But there are some consequences. And, the hard thing about this is, again, knowing what to do and when to do it. And sometimes you just don't know. Sometimes you need to have like your principles guiding you. But, you often find that principles sometimes contradict themselves. If you take the Amazon leadership principles, which I'm somewhat familiar with, having worked at Amazon and having interviewed for Amazon, a lot of people will notice that, hey, wait a minute, these principles contradict each other. They say dive deep and they say bias for action. You could say dive deep would be the slow thing, right? Like dive deep and really learn all the little things. And you could say the bias for action is on the other side of that. And again, you need both. I don't know why nobody tells you this. Like nobody ever teaches you this. Even a lot of books don't really put it together very well. But like that comment said earlier, it depends. And you gotta, to put it psychologically, and maybe this will be a better way to put it for some people, if you kind of go inside your brain, think of your brain as a circle. One thing you could say, or I could say about my brain, is the slow part, I built that up pretty well. I mean, I didn't always know how to use it and apply it in every specific scenario, but that slow part was pretty strong in my brain. The fast part, I mean, for like math and physics and stuff, it was pretty good, but my bias for action part of my brain, the part of my brain that said, hey, I don't fully understand what I'm doing right now. I'm kind of uncomfortable. I'm not used to not understanding everything. I feel uncomfortable, but I'm just going to do it anyway. That part of my brain needed a lot of time to develop. A lot of time and effort went into that for me. Maybe you're in the same situation. Maybe you're in the opposite situation, or maybe you're somewhere in between. You kind of have to identify that, and through your experiences, your past experiences, your current situation, and your future experiences, have to figure out what's working and what's not. Let me give you a little bit of like a concrete example. One thing I've heard in the past, I remember when I was a student and on like online forums, there would be people asking, what should I learn? And one of the things were like cloud computing and stuff. Okay, I want to learn AWS. Everybody wants to know AWS. What do? They got 100 services, right? Well, the way my brain works, and having like been a programmer for several years now, and done used cloud tools. I worked in Google Cloud and stuff like that. The way my brain works is like by grouping things together, chunking, pattern matching and stuff like that. Now I can look at most AWS services, even the ones I don't fully understand, and I can take that and I can bucket it somewhere in my brain. I can say, okay, I don't fully understand the details of this, but I know what it is. Or is it a managed service? Is it just taking open source and just making a service out of it? Is this proprietary by Amazon? Is it storage? Is it networking? Is it compute? What is it, right? I can do that now, but when you're a beginner, you probably don't even know what words I just said. You don't know what they mean. And so when you're in that situation, you don't want to overthink. You don't want to think too slow. I mean, you don't want to get like a crazy AWS bill or anything like that, so be careful about that. But you just want to kind of go fast. One of the advice that I heard for people were, hey, just get a Linux box and just play around with it. Use EC2, get a box and play around with it. And that was probably advice from a seasoned programmer. But the advice was exactly correct. In some ways, it's kind of like telling a kid, just start mashing buttons, just start playing it. Don't read the manual just yet. You won't even understand what it means. Just start playing around with it. And what that person kind of meant was that again, like it's kind of hard to give somebody that advice, because if they hate it, if they have zero curiosity, if they're not curious, or they're not like actually in that mindset of take a Linux box and play around with it. See what you can do. SSH into it. Use it as if it's a remote computer. See what you can do. Learn from it. Kind of the same way that I should have been approaching Docker. I didn't know at Docker, hey, you can just kind of run the shell within a Docker container, and it's like, oh, so it's kind of like its own little isolated computer that's, using like the host system and little things like that. But even that, right, like includes a little bit of jargon. So again, sometimes you need to go fast, sometimes you need to underthink, sometimes you need to overthink. Step back, read through what exactly you just did. First, just go through the Docker quick start. First, just go through some AWS commands, do some basics, and then take a step back and really understand a little bit about what you just did. Try to recognize when you're going a little bit too deep and you're overthinking, and try to recognize when you've copy and pasted a lot of code and now you don't quite understand what you just did or what you're doing, and now you gotta switch between the two. Very hard to do that. I could spend 10 hours talking about it and give you 10 more anecdotes from my own life, but this is the part where now you have to start thinking about your life. Maybe you already know this stuff, but I don't think anybody knows it perfectly. Like, this is the stuff you kind of have to constantly remind yourself of and practice. I would encourage you, don't wait until it's too late to do this. Try to learn it as you go. That's why people say in college you should do clubs and you should build up your social skills. You should be networking and things like that, because there might be a part of your brain that's lacking or a part of your skill set that you haven't fully developed, and you probably want to focus on that. And again, like if you don't have any curiosity, it's hard to do that. If you're scared, if you're uncomfortable, it's hard to do that. It does take practice. It's not like a one-dimensional thing. But also recognize you probably have some skill set. You do have your own strengths and weaknesses, I promise you. Because if you tell me you're really, really bad at something, I guarantee that makes you good at something else. I guarantee it. And maybe, to some extent, everyone has their strengths and weaknesses. That's part of the reason why I feel like I could be a good software developer. I believe I could. I could become a senior developer. I could maybe even climb the ladder and get higher than that. Maybe I could even become a manager. But those are certain things that I wouldn't fully enjoy doing. I don't enjoy building software when I don't understand a lot of the parts of it. I like going deep. My brain is probably a bit more wired for academia and research and math and those sorts of things, algorithms and data structures, than it is building things, like even learning things about like deep distributed systems. Frankly, I think I know more than many senior programmers. And you're probably thinking, well, how can you say that? You're just talking out of your ass. Well, let me tell you something that a lot of mostly students and juniors naively don't understand, and it's that when you work at a big tech company like Google, do you think they just hand you a book, or all your colleagues will just kind of teach you everything you need to know? Do you really think working as like a back-end developer at Google or Amazon, that alone is going to teach you distributed systems and how to build highly scalable systems? It's kind of the opposite. A lot of those managed services do most of the work for you. Most people at Google and other big tech companies actually don't understand what's going on, because for them to be good at their job, sometimes it's better if they don't understand those things. And the people that do end up like gaining a deep understanding, it's usually because they themselves are curious and they're learning on their own time. If they're given a project and they need like certain knowledge of distributed systems and back-end technologies and like deep internals and things like that, it's expected that they learn those things largely by themselves. I mean, yeah, you'll have colleagues maybe give you some recommendations, teach you about like how the system works and little things, but largely you're learning it by yourself. Just like in college, your professor will give you the homework and kind of guide you a little bit, but you got to learn most of it yourself. Just like this thing that I'm talking about. I don't know about you guys, but nobody gave me this advice in my life. I kind of had to figure it out myself. I guess there's books written on it, Thinking Fast and Slow, but I doubt that book had the exact same message that I did, that I talked about. Maybe it did, maybe I'm wrong. But before I start rambling any further, I think I've kind of made most of the points that I wanted to make, but I'd be really interested to hear what you guys have to say.